Hey guys, and welcome back. We just have a few lessons left in our Unit 1, which is all about matter. And today we're going to be talking about states of matter and phase changes. Now, there are three states of matter that we've already touched on a little bit, but today we're going to go a little bit more in depth. So the three states of matter are solid, liquids, and gases. And we have to know what the particles are doing in each of these states. So a solid has a definite shape and volume, and the particles are arranged in order. So if you look around your desk, you probably have a lot of solids sitting in front of you right now. Your Chromebook, your pencil, maybe if you have a notepad or some paper, a water bottle or a drink close by, or I should say a drink bottle. But those have definite shape and volume, okay? Their particles are arranged and they're tightly packed, and they have something called a low kinetic energy. Next up, we have liquids. So liquids will take the shape of the container that they're in, and the particles will move and slide around. So we know liquids as water, soda, coffee, tea, anything that you can drink is going to be a liquid, right? So if you have a water bottle close by, the water bottle itself would be a solid, and then the water inside would be a liquid. Then we have our gases. These do not have a certain shape, and their particles move fast and freely. So our gases are going to have a high kinetic energy. So our kinetic theory of matter, we know that matter is made up of particles and they are in a constant state of motion. And that kinetic energy is just the energy of motion. So when we talk about solids that have tightly packed particles that have definite shape and volume, the particles are not going to be moving as much. So our solids will have a low kinetic energy. And then as we move up to our liquids and then our gases, the more those particles are moving, the more kinetic energy they have. And then, of course, our temperature is just going to be a measure of the average kinetic energy. So if something is warming up, the kinetic energy is going to increase. If something is losing heat, typically the kinetic energy is going to decrease. So matter exists at these different phases, and it depends on its kinetic energy. So again, when we have our solids that are tightly packed, here we would have a low kinetic energy, and then that kinetic energy would increase for a liquid and then increase again for gas. So gases have the highest kinetic energy, and then solids would have the lowest because, again, those particles are tightly packed. They're not moving around as much. So these states of matter can change. They can go through something called a phase change. And this is done by either adding heat or heat being taken away. So heat makes particles heat up, which causes them to change states. And a really good example of this is going to be water. So we're going to talk about these phase changes here over these next couple of slides. So here we have water and the different phase changes that will happen as we add heat. Okay, so we've got our temperature on our y-axis, and this is changing in relation to the amount of heat that's added to the system. So here we're starting with solid ice. Okay, so this is ice, it's frozen. So as we add our heat, eventually, we're going to reach the point where this ice is going to melt. So where the temperature, where it reaches its melting point. Once it reaches its melting point, it's going to go from a solid to a liquid. Okay? So we're going to exist as a liquid once we have reached our melting point. Well, if we continue to add our heat, so if we continue to heat up our now liquid water, eventually our liquid is going to meet its boiling point. Okay, so here's an image of it on the screen where we have our water, it's being heated up. And when you heat water and it reaches its boiling point, if you've ever watched a boiling pot of water, there is steam coming off of the top of the water. And that steam is that water being heated and evaporating into a gas, which is the water vapor. Okay, so as we're adding heat, our water will go from a solid, which is frozen ice, to a liquid, which is liquid water, to our gas, which is water vapor. So as we add heat, we're increasing the kinetic energy. Those molecules are moving faster, and we're seeing these phase changes occur. Now, if we go in the opposite direction, the phase changes will still occur, just in a different order, right? So if we have our gas to start with, right? So we've got our water vapor. Then we have our condensation, which will take it from a vapor back into a liquid. And then eventually, if our temperature gets low enough, because if we see on our x-axis, our heat is decreasing, so our heat is being taken away, then we're also going to go back to our frozen solid ice, right? So we go from gas to a liquid to a solid as that heat is taken away. So instead of increasing the kinetic energy, we're decreasing the kinetic energy. So those particles are going from free and bouncing around and having a lot of energy to going back to their tightly packed formation in the form of that solid ice. Okay, so we need to know these phase changes, and the definitions are just on the screen. So the freezing point is the temperature at which a liquid changes to a solid. So that phase change is liquid to solid. Melting point is when solid changes to liquid. So think of melting ice. The boiling point is the point at which a liquid becomes a gas. So water going from liquid to gas phase. Evaporation occurs when the molecules change from a liquid to a gas below the boiling point, and occurs when high energy particles near the surface break the bonds and become the gas. Condensation occurs when we go from a gas to a liquid. So this would be like if you think of dew on the grass in the morning, the water vapor is in the atmosphere, and as the temperature cools, that water vapor eventually becomes or condenses back into liquid water, which we can see as dewdrops. And then sublimation occurs when a substance changes from a solid directly into a gas. Okay, and this is just a graphic that can help us. So it shows us our different phases. So we have our solids, again with our low kinetic energy, our particular shape and volume. We have our liquids, which are fluid and take up whatever shape container it's in. And then we have our gas with our high kinetic energy and its free-flowing particles. And if we follow the arrows, it will show you what phase change is happening as you go from each of the states of matter. So if we go from a liquid to a solid, this is freezing, right? So if we think about water going from liquid to a frozen ice cube, that's freezing. Solid to a liquid is melting. Solid to a gas is called sublimation. A gas to a solid is called deposition. Gas to a liquid is called condensation. And then liquid to gas is evaporation, boiling, and vaporization, okay? For this, you just need to be able to, when you're looking at this graphic, you just need to be able to follow the phases and then understand that this is the process that's occurring as each of these phase changes occurs, okay? So again, the takeaways is that there's 3 different states of matter: solid, liquid, gas. And then these states of matter can go through phase changes based on whether energy is added or taken away. Okay, remember, more heat equals more kinetic energy. We're moving towards a gas. Less heat, less kinetic energy. We're moving towards a solid. Okay, you guys have a practice to do with this today. You're going to read a little bit more about the states of matter and check yourself with a Google form. But of course, if you have any questions or anything at all, let me know, and I'll catch you guys in our next lesson. Bye, guys.